Hi, I'm Jerry Karata. Recently I spoke to Pete Warden of Google about TinyML. Pete leads the Tensorflow Lite for MicroController team, where they bring the power of machine learning to tiny low-power devices like this. Adding machine learning models to these devices creates solutions running at very low power on the edge. This also allows the models to be the engine of a whole new series of applications, running in settings as varied as factory automation, toys, agriculture, and healthcare. So join me now as we learn from one of TinyML's founders about the opportunities created when we bring machine learning to millions, or perhaps billions, of devices.
Hey Pete, how's it going?
Hey Jerry, thanks so much for having me on.
Oh, it's my pleasure. As I said, this is TinyML is one of the things I think is going to change how we view machine learning and where we take machine learning to. So I'm just so happy to get the chance to speak to you about it. Uh, Maybe we could start with a little bit about you. TinyML is kind of this funny sort of hybrid thing, right? Where we have hardware, software, and people doing all sorts. Are you a hardware engineer, software engineer, both, or?
Yeah, no, that's a good question. I'm definitely a software engineer, and I actually came from an application programming background, so I wasn't originally a machine learning person, but increasingly, especially over the last 10 years, a lot of the problems that I needed to solve were related to machine learning. And so I ended up building software to kind of like solve my problems that then started to become, more and more, I ended up, being one of the founding people on TensorFlow. And it really kind of just sort of ballooned from there. I started off trying to sort of scratch my itches and solve a few problems that I cared about, and eventually it ended up becoming this whole this whole big infrastructure thing.
Well, sometimes you think it's only your problem, but really it's a lot of other people, right, that are having kind of the
Yeah.
same issue. So what do you do now at Google these days?
So I'm really interested in, as you might have guessed, the whole embedded machine learning space, like trying to do really interesting things on these tiny, tiny devices and in tiny amounts of memory. Um, and the way I got into that, my first exposure to it was actually when I joined Google. Wow, it must be like 7 years ago. Um, and I'd been working on software that let you run machine learning on phones. So I thought that that was pretty sort of, cutting edge and pretty tiny. We were able to, get these neural networks down to just like a few megabytes. Um, and one of the first people I talked to at Google was actually Raziel Alvarez, um, he actually recently moved over to Facebook, but he had been working on the OK, and I'm going to pause a little bit so it doesn't trigger everyone's devices. Google, um, because we called it OKG internally, so it doesn't like set off everybody's phones. But the
Now that we're in the family, we can use the OKG word. How's that?
Yes. um, and I was feeling pretty pleased with having, like, yeah, yeah, we've got this model down to like 2 megabytes, and he explained that they'd been running a 13 kilobyte model for recognizing for recognizing OKG on phones. So I was like, oh my god, that's incredible. And it really got me thinking, okay, well, if machine learning is still really useful at this smaller scale for this one problem, how many other problems could you solve, in this sort of domain?
Yeah, yeah. So, and then you're on the TensorFlow team now. I believe you're leading up the TF Lite for microcontroller group. Is that correct?
Yeah, yeah, that's right. What's really nice is with machine learning, there's so much, everything from like data gathering to training to
Hmm.
deploying your model, um, and being part of the TensorFlow kind of ecosystem means that I can like benefit from everything that's happening in the training side. And then what I focus on, and me and my team, is okay, let's see if we can take those models and really make them tiny and small, just a few kilobytes, and then get them out on things like the Arduino and the Raspberry Pi Pico and these really, really small and cheap devices.
Yeah, that's great. So maybe for people that are coming from the normal sort of machine learning that you just described there, could you give them some idea of scale of what you're talking about of these devices and things like that?
Yeah, so what's really interesting about all these devices is that they are designed to be the sort of things that you get in your, like, in toys and in washing machines and in remote controls and, in your toaster. So they have to be really cheap. Like often you can actually get I think the average price is now well below $1 when you're buying them in industrial
Oh, wow.
quantities. Yeah, so they're really, and you can actually buy a Raspberry Pi Pico for just $3, like retail. So these really are almost like disposable devices, um, but they actually have, which means they're very limited in the amount of like processing and memory they have. But they've actually, they've often got only a few hundred kilobytes of memory. There's no file system, there's no like real operating system even. You're kind of programming on the bare metal often. Um, but they actually have enough processing power to do interesting things like running person detection models or on an image that's coming in, or doing like the OKG, very simple voice recognition, or they often have accelerometers so you can do something like where you're actually doing gestures. We have a Magic Wand demo where you can do different Magic Wand gestures, and the board actually recognizes those and like does something useful based on each gesture.
Yeah. Um, but in the larger space, you guys are getting a lot of interest, I should say, from these, industrial level companies, Arduino, various companies and things like that. Obviously, they're not just going to build magic wands out of their things, right? They're going to build something. Where are they? Where's this going? I mean, what are we going to be able to do here with this technology?
Well, what's been really interesting is seeing people building all sorts of really useful and interesting devices that can go out in the world. Because that's what's really different about these devices compared to even like a normal Raspberry Pi, where you need a kind of a phone battery pack and you need to keep recharging it. These devices can run on like AA batteries for like a year or something like that. So you start to have all these applications where you're putting these devices on like machinery in a factory, for example, to tell when it's going to need maintenance, because it's often hard to kind of like wire in to the mains.
Yeah, yeah.
There's one of my favorite applications was actually somebody put together a little ESP32 with a camera and is using TensorFlow Lite for micro to actually read the dials off a water meter.
I mean,
So
like old style 20, 30, 40, 50-year-old water meter meets latest high tech type thing.
exactly, and if you think about what you'd have to do to put in a new connected water meter, you'd have to
Yeah,
have
right.
somebody come in, attach it, do all the plumbing, take it out, put a new one in, have some kind of like mains power to sort of power it or whatever you're going to do with that.
Hmm.
Um, And by just taking this like $5 ESP32 with a camera on it, and pointing it, having it battery powered and just pointing it at this this old school display and then transmitting it like that, you've suddenly like saved a massive amount of work and
Nice.
money. So
That is creative, isn't it? Is that something you did, or
no, this is actually,
no,
that's the
no?
good thing. Yeah, like somebody
Yeah.
somebody out there, I actually ran across it one day and I was like, oh wow, this is so neat. I'd never even, I see, I don't have the imagination to think of that. Um,
Yeah, yeah, me neither. There are a lot of creative people out there. Unfortunately, I'm not one of them, but
yeah.
good for them, right? Uh, Now, how is it difficulty-wise to build something like that? I mean, to build something like a little, camera that reads a meter or something like that.
Well, the good news is that there's this really impressive world of software, sort of IDEs, development environments, operating systems, tool chains, documentation around all of these different things like the Arduino, the ESP32, the Raspberry Pi Pico is a new entrant. And so a lot of these tools make it really straightforward, a lot easier than it would have been like
Mhm.
even just a few years ago to
No.
get something up and running. And then what we've tried to do with TensorFlow Lite Micro is then slot into those existing ecosystems and just say, okay, you've got, the lights blinking, you've got the sort of,
Mhm.
the basic stuff up and running on this board. Guess what? You can now actually do some of these machine learning examples that we give you to
Right.
do, speech recognition, to do gesture recognition using the accelerometer, to kind of access the camera.
Okay, cool. One thing I've always heard is in terms of scale, how many, if we think in terms of deploying to a data center, you might have tens of thousands, maybe, hundreds of thousands. But I'm hearing in terms of worrying to TF Lite and these little micros, you're talking not millions, but billions. Am I, is that
Yeah.
true?
Well, the interesting thing is that there's so many more of these embedded devices being shipped every year than there are any other kind of computer. I think ARM, ships tens of billions of just their kind of embedded controller every
Wow.
year. So um, now it's obviously it's early days for TinyML. It's not I don't have any figures I can point to saying, hey, look, this is on billions of devices yet. But the the promise and the potential is really clear because these devices are already out there. If you can actually just through software make them smarter and make them more useful through machine learning, then it's really exciting to think about
Yeah.
how many uh, places they could end up.
Yeah. Yeah. Well, speaking of that, I mean, I've heard, when I look up and say, what can you do with TinyML? One of the things they show are things like medical, which we, on device, like on a human, right? Type thing.
Yeah.
I've seen things where you could maybe put a little camera, like in a farmer's field, and detect if that the bug is, a pest or a beneficial bug, that sort of thing. Where else do you see them going with this technology? I mean,
So it's kind of a silly example, but it's one that stuck with me. Is back when we were still working out of the Google offices. If there was a really boring
back in
meeting,
those days.
yes, in the before times.
Oh, yes.
um, if there was a really boring meeting and everyone was sitting still, then the lights would go off because the lights depended on this sensor that detected movement. I just want to have something that actually tells if there's people in the room,
Uh,
even if we're bored stiff. um, and doesn't turn the lights off on us. And also, does things around like, being intelligent with the air conditioning and all of that other stuff so that you're not wasting energy. So I think there's all of these things you can do there. Another space that I'm really interested in is voice interfaces. We have this kind of OKG level of like recognizing one word running on TinyML, but if you could have a full voice recognition system running on this like 50-cent chip, and especially if you imagine that you can use the camera to tell when somebody's looking at the device, so you
Oh,
don't have to, because one of the problems I picture is that we're going to be surrounded by all of these devices with potential voice interfaces. But how, you don't want them all responding at once when you say stop.
well,
um,
or that's the OKG problem, right? If you have two of them in your office and they both respond back to you, right? Or
yeah,
something
they're
like
both like, hey. So I love the idea of just being able to do, gaze detection with the camera, and
uh,
potentially also doing things like helping, lip reading to help understand what you're saying, even if the even if the environment's a
uh,
bit noisy. So if we can put all of that onto one of these tiny embedded chips, then you can imagine anywhere that there's a button or a switch right now, you could either replace it or have this additional sort of little
right.
controller thing that you just wire in that understands like a few simple commands. And then like everything in your world can have a voice interface, which I think could be uh, really fun and useful.
Yeah, yeah, that sounds really neat. Yeah, and I'm starting to get the where the billions number comes from now. Because
Yes.
if you think about that, every light switch in a given house, or thermostat, or whatever, that sort of thing, having those, yeah, that I can really see. Um, Now, getting back kind of to the TinyML side, I mean, your the work you do at Google and things like that. Uh, I know with the tinyml.org that you helped co-found and things like that. I get on there every week on the Tuesday con calls when I can, and I noticed that you know oh, they're not a lot of soft. There are some software developers, but there are the Arduinos, the ARM, the those sort of people. So you guys are getting a lot of traction with those sort of guys. Is it because of these numbers that's happening, or?
Well, I think one thing that's been really interesting has been um, microcontrollers have been getting much, much better at doing compute. Like they've been bulking up. They've really been, getting swole, I think the kids would say.
but still, I mean, could you give us kind of, where are we on these big, pumped up microcontrollers in terms of memory and CPU cycles? I mean, maybe so people that aren't familiar with that space, can still.
Yes. Well, they've actually been getting, they're still, compared to a desktop machine, you might still only have like 100 megahertz or 50 megahertz clock speed. But what's been interesting is that they've been getting like acceleration either through things like SIMD, or they're starting to actually get dedicated neural network accelerators like integrated with these very small chips. um, and it uses very like usually the thing that is the um, really hurdle for these devices when they're being deployed is how much battery power they're using. And it turns out that doing all of the compute is very, very cheap in terms of energy usage compared to anything else like radio or anything else that they might do.
Mhm.
So what's happened is that these companies have built these devices that are really, really capable of running a lot of computation, but they don't have this wide it hasn't traditionally been this wide range of things you can do with that compute. And so machine learning comes along and is like, hey, give us more compute and we'll give you all of these really great results. And so it really is like kind of a match made in heaven, that the hardware has kind of got all these new capabilities that in some senses they're kind of like trying to figure out what to do with. And we kind of come along with the machine learning world and say, hey, we've got all of these neat applications we can do if you just give us more compute.
Yeah. Yeah. Okay. And then the price of these things seems to be going down too. I've noticed over time, as
Yeah.
a experimenter, what I would have paid maybe $30 for now, 3 years ago or something is dropping under, down to 10-ish, the bracket or things like that, right?
Yeah.
But and in terms of memory though, we're still talking, we're not talking gigabytes of memory, right? Like, anyway, we're still talking, how big are we talking in terms of, memory size?
So usually just a few hundred kilobytes at most.
Hmm.
So that's one of the biggest challenges is you have to go from this world where you expect to have, many megabytes of
Hmm.
space to do your model in, to really try to fit in a very small area of memory. So for example, TensorFlow Lite for microcontrollers, one of its design goals is that we have to we have to be able to run with just 20 kilobytes
Oh
of
my.
program space. So we're really sort of, kind of trying to, work in miniature. And it's in a lot of ways, it's kind of fun. It's like going back to the 80s or something. Um,
Yeah, I don't think many developers remember that, Pete. I'm sorry to say. I do. Notice the
I
gray
know.
hair.
Yeah, exactly. I'm showing my age too. So
Yeah, yeah, yeah. Okay. Well, what goes around comes around, that sort of thing.
yeah.
But and I noticed. I will say I've read your source code in TF Lite for Micro, and there's some very interesting comments about, oh, I'm doing something terrible to this loop, so I can save a few, like two. I don't know if that was your comment or somebody
That,
wrote that
that
in
that
there.
was I know exactly in the testing code.
Yes, yes, this is the tenth. Is that you?
That was me.
Oh,
I, I felt so sorry for that poor. I mean, honestly though, that's part of the part of the fun is I get to have an excuse to do kind of really heinous things in the names of efficiency, which I'd never be able to get away with if we had more memory. I'm like, well,
yeah.
yeah, I just have to.
Now, that brings up, I guess, probably the debate over language and things like that. Most machine learning people are Python people. TF Lite for Micro is C, or is it C++ or just C?
C plus plus.
C++. It's C++. It's not a
Yeah,
Python library. And that
yeah.
I assume has to do with performance and memory usage and things like that.
It does. What has been interesting though is that there's a variant of Python called Circuit Python,
Mm.
or also there's a slightly related version called MicroPython,
Hmm.
which actually takes Python and shrinks it down to run on these microcontrollers with just a few hundred kilobytes of
Oh,
memory. So that's if you are really, if you're very familiar with Python, you can actually use that on the Raspberry Pi Pico, um,
I,
and
uh-huh.
Adafruit also have a bunch of boards which support their variant of Python.
Mhm.
So it's totally possible to get into get started with some of these boards using Circuit Python or MicroPython.
Mhm.
We also have some community members out there who have been adapting TensorFlow Lite Micro to kind of interface with these versions of Python.
Mhm.
So that's been really good to see. They're not, I think, fully. They're still in sort of alpha or beta state.
Mhm.
They're not. I don't think they're ready for sort of prime time yet. But um, don't be too scared if you're not familiar with C++. You can still do some really interesting stuff.
Yeah, that's good because the we do have that, large number of Python developers out there, and
Yes.
it just is what it is, right? Coming out of academia at that time, like that. And then this all fits into kind of the Google ecosystem, right? I mean, when I went through your examples on TF Lite for micro, until you got to the point where you were actually pushing to device, you were just in a more traditional workflow, shall we say, that somebody that's using TensorFlow, I mean, the big TensorFlow, right, the big capital TF, would be very familiar with. Is that correct?
Yeah, and you can do um, lots of stuff in Colab. Like we've set
Mhm.
everything up so that you can just use Python and Colab, and you can just go to the examples in GitHub and click Open in Colab, and you should be able to run through, everything up to deployment. And we've actually also been working with a software framework called Renode, which actually emulates these devices. So we also have some examples of taking Colab and running through the training, but then actually within that same Colab running the
Mhm.
emulator for these devices and actually being able to see the results from like the Hello
Oh,
World program,
mhm.
even without having to have a physical board. So yeah,
Wow.
we do try very hard to be accessible to people who are familiar with, the wider Google ecosystem.
Yeah, yeah. I know everybody. Anytime I talk to somebody, the C thing is a bit of a barrier, and
Oh yeah.
then the idea of having to maybe go to the Arduino sketches and things like that, or whatever the microcontroller is, becomes a bit of a barrier. So that's great because each one of these microcontrollers seems to have their own quirks. Is that a
Yes.
good term? Oh, they're
Oh yeah.
unique, right? Yeah,
Yeah. No.
and
No.
for good reason.
Yeah. And I will say, like, stay tuned as well because we are looking at some, ways to make this stuff even more accessible.
Hmm.
Through having some even easier on ramps to connect into these devices and actually getting models up on them. So um, don't worry, yeah, and don't be too scared by the idea of getting into all of this complexity. Like, hopefully, we're doing our best to make it as approachable as possible.
Oh, great, great. And this leverages if they have already TF Lite skills, not for micro, it still leverages all those, and so they can
Yeah,
move up and down the whole TensorFlow stack of products and things like that.
exactly. That's the idea.
Okay, cool. And then for learning resources, I'm going to embarrass you and show people your book that you and Daniel wrote. No, this thing is
Yes.
honestly is very, very well written and things like that. And it's one. This is my own personal copy, so nobody, you guys can't have that. You're gonna have to go buy one from Amazon. Things like that. Uh, and just as a final question here, I know you have to go because this is a work day type thing. Um, uh, why you guys did you write the book to kind of just to lay it out for people, or was this just something that you had to get out of your brain, or maybe all of the above and things like that?
Yeah, I mean, I just really, um, when I looked around, there were lots of kind of scattered resources, but I always learn by sort of doing something myself. And
Hmm.
so I kind of wanted to just pull together these very practical examples of like step by step recipe with all of the steps included
Uh,
so that I would be able to partly just really figure it all out myself and make sure we had a good end to end experience, but also yeah, hopefully kind of set other people up for success. Like because I was hoping that the way we put the book together was going to be something that would actually get people, to feeling like, hey, yeah, I've actually done this. I've made something here. This is all working.
right, right. Well, it does work. I myself have, actually, this is my personal dog-eared copy, so I really appreciate you putting it through. And the other thing I appreciate, and I'm going to embarrass you again, is at one of the TensorFlow summits, you did a demo and you showed us this little Spark fun, and you gave everybody in the audience one of these so they didn't have to go out and get something. And I really appreciated it, and I'm sure everybody else did. Because I believe they were unavailable at the time, right? Weren't they some sort of
Yes.
like prototypey thing at the time? And
Yeah, and that was a massive that was a crazy scramble because I was trying to get these boards actually built. Like I was collaborating with SparkFun, and we had this massive we only got them like a day or two I think before the show, and we weren't sure that they were actually going to come through because it was like the Chinese, New Year, and it was it made me glad that I'm not in the hardware business.
and you thought software was difficult.
Yes, there's a reason they call it hardware because it's hard.
So one last question about the book. If you know, I've interviewed other authors that have O'Reilly books, and the choosing of the animal is a non-trivial, I guess, sort of thing. How was it for you guys?
Well, I've never had the choice. I've always been O'Reilly have always, but luckily, they've. I was very pleased with the hummingbird because my
Uh-huh.
previous two gigs with O'Reilly, one of them was a bull I had on the cover, and another one was a walrus. So
And these were your choices, I assume,
those were
right?
not my choices. They were all kind of related to big data and things like that, but. So I get why they did it, but I was glad to have a nice trim, lightweight, cute little hummingbird. I was very pleased that they chose that for me.
Yeah. I guess with the word tiny, a bull or a walrus would
Would
have been,
not, yeah.
yeah, it just doesn't convey the same meaning. All right. Well, Pete, I don't know what to do except I got to go program here. You've inspired me. I'm going to get hands on. I did C++ for decades for Microsoft, and I'm going to, get that out there and get it going. So thank you so much for, or helping us create this TinyML world and the book and everything, and the wonderful TF Lite for Micro framework. We really appreciate all you've done.
Oh, thank you so much for those kind words, Jerry. And yeah, this
Uh,
has been great. It's been really fun chatting with you. And yeah, and people out there, I'm pretty easily findable on Twitter and other places. Feel free to ping me and ask me questions.
mhm.
I'm always happy to hear, especially if people are doing neat stuff with this.
Yeah, and do you want to give a plug for the tinyml.org or?
Yeah, yeah. No, I mean, I think you can go to tinyml.org. You can find about meetups. You can also find, we do monthly meetups. We used to do them in person in different cities around the world. Not so much anymore, but you can still log in. You can find there's some forums there, and we have an annual conference as well. So there's lots of really neat stuff there if you want to check it out.
Yeah, yeah, and I actually think, for better or worse, having that online is, I've seen people sign up from, around the world, so,
Yeah.
and they probably couldn't have done the in-person one. So maybe there was something good, out of these before times or whatever we call it.
Oh, and the other
Okay.
thing
Oh,
I'd give a quick plug for as well is there is an edX course together with Harvard that's free. You can take it for no charge. So if you're interested, that's another nice complement to the book as well. So I'd recommend checking that out.
okay, great. All right, Pete, thank you very much and all the best.
Okay, thanks, Jerry.
Okay, take care.